Hello, this is a quick introductory video into what AMI is. AMI is a lead acid battery protector for off-grid solar systems. Just like to point out, this video is for information purposes only. So this is an AMI. This is actually a production AMI, because, well, a prototype AMI, because I've got the headers on. A normal production AMI doesn't have the headers fitted. You could fit your own headers if you wanted to try and reflash the EEPROM microcontroller, but I shall give you a quick tour of that. So this is an AMI. You've got a DC-DC converter here, little PIC, which is your microcontroller that controls the system, a couple of indicator lights, a reset button, and an output relay. Now when you get your AMI, you're going to need to solder wires on to connect it to. You've got your ground terminal here, your plus terminal here, and these are two output connections for your relay. This is a 24 volt relay, AMI. There will be a 12 volt version coming, but the 12 volt version will still have 24 in. The only difference between the two is a firmware change and resistor values changed. The indicator lights here, so you've got fully charged, half charged and empty. But yes, so when you first get one, these will require soldering, and I shall solder this one up now. The pads are available to be soldered to. Just a quick example of how these are soldered together. Just using that there, just to hold the wire. I'm just going to tin. Just makes it easier to solder to in the card. And then there are two holes, both equal sizes, that you can solder to any one. Just put them in like that. You could do whatever you wish here, just to make sure that they're fitted firmly. You could do it like that. You could go back through the hole. Do it like that. You go back through the hole again, make it more rigid, firm, secure connection. I'm just going to do it like that for now, just to demonstrate. So have it fitted like that, and then just trim off the end bit there. We have our first connection. Do the same on all four for however length of wire that you need to connect it to your system, and then we'll get on with testing it. So this is my test setup I've got here. I've got an AMI wired up to a power supply. This DVM down here is measuring the input of that power supply, so effectively your battery voltage. Got another DVM here on resistance measuring the output of that relay. So that relay, we can tell through this if it's open or closed. So at the moment we are closed, so we've got low resistance. We've got 0.2 of an ohm, so the relay's closed. 25.10.1 volts, and we've got a green LED to indicate the batteries are good or in a good state of charge. Now as we reduce the power supply, reduce the input voltage, you see it's starting to come down now. We have a orange light lit up to show the battery is discharging, and now we've got a red and orange light to say that we're getting quite low, so the battery's now getting to 24.2 volts, so we're getting near to a danger point. And as we get lower still, red light comes on, red LED starts to flash to indicate that the batteries are low. The relay's tripped, so we're now open circuit to turn off our load or whatever you had connected to your batteries. So the batteries are now no longer discharging. Then your solar panel should charge these batteries back up again. And as they do, you'll see your indicator lights will also still indicate the battery voltage, but they will be flashing this time to let you know the load is not connected. As the lights batteries continue to charge, let's increase. So we're now fully charged. The lights have stopped flashing, gone to this pattern. This is to indicate that the batteries had tripped, or this AMI had tripped. And then it will stay like this for 3 hours, and then after 3 hours it will reset, and then the relay will come back on. you can make this happen earlier by pushing the reset button that's on here. Push that, and we're now back to green as we were before. Relays kicked in, and we're all good to go. So this will hopefully have saved your batteries from being over discharged if you leave something on for too long. Thank you. So this is my setup, and it's a standard charge controller. So solar in, charge controller, then that goes off to the batteries to charge. On the batteries, got an inverter. But what I've got different here is I've got the AMI setup, so that the AMI is in series with the power switch of the inverter, and then the AMI is also wired directly to the batteries to monitor the battery voltage. And that's the panel I'm using. It's one 250 watt solar cell. So I've got here 4 lead acid batteries, and they are wired together in series and parallel to make 24 volts at 200 amp hours. And then that goes into my charge controller. So this is my AMI I've got in my shed. So what I've done here, which is unusual, I've taken the LEDs out and I've wired them instead to a jumper box, and then got the LEDs mounted here and here, and that's so I can see the battery status and charge from the house. And then the output of the relay I've got going through this cable, which is a bit too long really, but going through here, round all the way, convoluted into the inverter, and then that's in parallel, in series with another switch I got in the house. So I can turn the inverter on and off from indoors, but yet AMI will turn the inverter off when the battery gets too low. And again here I've got the input of AMI wired through this into here, which is the batteries. The wire from the batteries goes through this meter, so I can read the battery voltage and then down to where the batteries are stored.